Steel fabrication. Fabrication procedure. Fabrication of steel can be done in shop and on site, both as under described. In shop, fabrication work is precise and of assured quality. Shop fabrication is efficient in terms of cost, time and quality. On site, field fabrication is comparatively of inferior in quality. It is common in India due to lower rate of field labor and high transportation cost. Difficulty in transporting larger members. Sequence. Here, the sequence is described for how fabrication is to be done. 1. Surface cleaning. 2. Cutting and machining. 3. Punching and drilling. 4. Straightening, bending and rolling. 5. Fitting and reaming. 6. Fastening, bolting, riveting and welding. 7. Finishing. 8. Quality control. 9. Surface treatment. 10. Transportation. 1. Surface cleaning. Structural sections require surface cleaning to remove mill scale prior to fabrication and painting. And it can be done by hand preparation, such as wire brushing, does not normally conform to the requirements of modern paint or surface protection system. Blast cleaning is the accepted way of carrying out surface preparation. Abrasive particles are projected onto the surface of the steel at high speed by either compressed air or centrifugal impeller to remove rust and roughen the surface before applying the coating. 2. Cutting and machining. After preparation of surface, cutting to length comes next. It can be done by following methods: shearing and cropping. Sections can be cut to length or width by cropping or shearing using hydraulic shears. Heavy sections or long plates can be shaped and cut to length by specialist plate shears. For smaller plates and sections, machines featuring a range of shearing knives, which can accept the differing section shapes, are available. Flame cutting or burning. In this method, the steel is heated locally by a pressurized mixture of oxygen and a combustible gas such as propane, which passes through a ring of small holes in a cutting nozzle. The heat is focused onto a very narrow band and the steel melts at 15,000 Celsius when a jet of high-pressure oxygen is released through a separate hole in the center of the nozzle to blast away the molten metal in globules. The desired cuts are obtained quickly by this process. Arc plasma cutting. In this method, the cutting energy is produced electrically by heating a gas in an electric arc produced between a tungsten electrode and the workpiece. This ionizes the gas, enabling it to conduct an electric current. The high-velocity plasma jet melts the metal of the workpiece. The cut produced by plasma jet is very clean and its quality can be improved by using a water injection arc plasma torch. Used on thicknesses up to about 150 mm, but the process is very slow. Cold sawing. When a section cannot be cut to length by cropping or shearing, then it is normally sawn. All saws for structural applications are mechanical and feature some degree of computer control. There are 3 forms of mechanical saw: circular, band and hack. 3. Punching and drilling. Shops have numbers of machineries which can make holes for the connection of members in steel framework. Traditionally it is done by drilling machine, but as it is manual it is slow. Larger fabricators have installed NC, numerically controlled, tooling, which drills in response to keyed-in data. It can make many holes in flanges and webs of rolled steel sections simultaneously. Punching holes is also possible, and useful where square holes are specified, such as anchor plates for foundation bolts. 4. Straightening, bending, and rolling. Rolled steel gets distorted due to cooling process during transportation and handling operations. Also occur during punching operation. Therefore, before conducting fabrication it should straightened. In practice it is done by either rolls or gag press. Gag press is generally used for straightening beams, channels, angles, and heavy bars. Misalignment in structural shapes are sometimes corrected by spot or pattern heating. 5. Fitting and reaming. Before final assembly, the component parts of a member are fitted up temporarily with rivets, bolts or a small amount of welds. The fitting up operation includes attachment of previously omitted splice plates and other fittings and the correction of minor defects found by the inspector. 6. Fastening methods. The strength of the entire structure depends upon the proper use of fastening methods. There are 3 methods of fastening, namely bolting, riveting, and welding. 7. Finishing. Structural members whose ends must transmit loads by bearing against one another are usually finished to a smooth even surface. Finishing is performed by sawing, milling or other suitable means. 8. Surface treatment. It is required to protect steel surface by corrosion. This can by applying metal coating, paint application, anchor bolts type by material, mild steel, MS. Least expensive. Most commonly used. Weldable and very hard, though it rusts. N8. It is tough hardened with higher carbon content. Has higher elongation properties than MS. Structural columns. Anchor bolts. Grouting upon alignment. Anchor bolt template. For fixing anchor bolts in correct position, template is used. Ensure proper number of templates are fabricated to assist in anchor bolt casting.